Hey, and welcome to Meetings in Math. You are here for section 8.3, Areas of Circles. Our essential question is, how do I find the area of a circle? Today you are going to need your Jaguar Jots on section 8.3, a pen or a pencil, you may find a highlighter helpful, a calculator, your self-confidence, your best effort, and always bring your problem-solving skills. Let's begin by looking at some vocabulary. The area of a shape is the space occupied by a flat shape or the surface of an object. Before we begin any problems, let's develop the area of a circle formula. So let's say we have a circle and we cut it into evenly spaced rings. And then what we did was we were able to take those and unroll them so that they were straight lines and that didn't stretch them. And then what we did was we stacked them one on top of the other and made this new shape. And I want to know what kind of shape is this. So if I was to outline this shape right here, what did I just outline by doing this? I outlined a triangle. So now that we understand that that's a triangle, how does the area of a polygon compare to the area of a circle? Okay, so what I'm saying is, what do we know about this area and this area? Well, since I didn't stretch it and I didn't take anything out, I just rearranged it. It means that the area has to be exactly the same. So in this case, I stacked them, and in this case, they're nested together. But they have the same area. So then what's the area for the polygon? So what we're asking is, what's the area for this one right here? So the area of a triangle is 1/2 base times height. Now this is where it gets interesting. So if we know the area for this, how can we use that to help us find the area for this? Well, we're going to use the circle measurements and the formula for the area for the triangle to help us get there. So watch. We know that the base of the triangle, so this right here, that's our longest piece, is also the part that goes around the circle. That would make it the circumference. And we know that the height of the triangle, that means what went from the top to the bottom, so what went through all of the pieces here, also has to go through all of the pieces in the circle. That would make it the radius. So now we could talk about the triangle, 1/2 base times height, as the circle, the circumference, and the radius. So the base, instead of calling it the base of the triangle, let's call it the circumference. And instead of calling it the height, we can call it the radius. But circumference has a different way we could talk about it. Circumference, we can talk about it as pi times diameter. So let's replace circumference with pi times diameter. But diameter, we can talk about it as 2r. So I just replaced diameter with 2r. So I know 2 divided by 2, that's 1. So that could go away. And now I'm going to have 1 times pi. Well, that'll just be pi. And then r times r would be r squared. So pi times r. So now I have the area is equal to pi r squared. We now have a formula for the area of a circle. Pretty nifty, if you ask me. And if that didn't make sense to you and you're going, whoa, that just, wow, that's mind-blowing. That's okay. It's just a really nice thing to know that it didn't come from nowhere, that there's an actual reason behind it. So what do you need to know? You need to know that the formula for the area of a circle is A equals pi r squared, and r is the radius. So now that we know that, let's go do some problems. So find the area of the following circles and semicircles. So right here we have a circle. And the first thing that we're going to always do is we're always going to begin by writing the equation for the area of the circle, whether we're finding the area of a circle or a semicircle. So area equals pi r squared. And then I like to always write down all of those variables so that we know what it is that we're looking for. And then we fill in what we know. We know pi is 3.14, and we know the radius is 6 because this one's going from the center to the edge, not the diameter. And then we fill in what we know by substitution. So now we're going to evaluate and finish the answer according to the directions. If the direction didn't tell you what to do, we are either going to leave it in terms of pi, which is what I'm going to do first, or go to the nearest hundredth. Either one is going to be just fine. So 6 squared is 36. So our answer, pi times 36, looks a little weird. We always go 36 pi. So this would be the correct answer if you were told to leave it in terms of pi. But it didn't tell us what to do, so we could replace pi with 3.14 and multiply that out and get 113 400ths. Don't forget your units. These are centimeters squared because we're in area. Area is in square units. So in our next one, same thing. Always begin by writing the area of the circle's equation. So area equals pi r squared. Write down those variables and fill in what you know. So I know that pi is 3.14 and our radius I'm a little shaky on right now because that 10's not a radius. That 10 is a diameter, but it's not that hard to get to radius. You just divide it by 2. So radius is 5. So radius is 5. I don't get too hung up on you showing me that you divided it by 2 because most people can go pretty clearly between one and the other just by looking at the diagram. So you don't have to show you divided by 2, but if you need to, go ahead and do it. So now what do? You substitute into the formula. So when you substitute in the formula, you're going to put it in parentheses so that you know you substituted it. You show that substitution. You don't skip a step. So now you evaluate and finish the answer according to directions. Again, if the directions don't tell you what to do, either leave it in terms of pi or go to the nearest hundredth. Pi times 25, but we don't write it that way. We write it 25 pi. You could stop here if it was in terms of pi. If not, you continue on by changing your pi to 3.14, and you get 78.5 centimeters squared. So again, now we have another one. This one's not a circle. This one is a semicircle. But again, we begin by writing the equation for the area of the circle. But this time we're going to go ahead and look at it. And remember, we want to divide it in half because it is a semicircle. So I started off with my original and then I said, oh wait, it's a semicircle. And so I changed it and I divided it by half. And I did that at the beginning so that I didn't forget to do it later on. I still write the variables out, what it is I'm looking for, and I go find what I know. The 3.14 for the pi, and my radius is 2 because it goes from the center to the outside edge. I still substitute into the formula just like I did before. My radius is 2. And then I go ahead and I evaluate and I continue to do the problems like I did before. But this time you have to make sure that you do your 2 squared first because exponents come first. So 2 squared is 4, and then you take half of 4, which is 2 pi. Now that you have 2 pi, that would be in terms of pi. Or you can continue, so 2 times 3.14 is 6.28 centimeters squared. So again, either the 2 pi or the 6.28 would be fine, depending on what you were given as directions. In this case, both of them are perfectly capable answers because the directions don't say. Okay, let's look at this one. Again, what is the first step? We always begin by writing that equation. So we write the equation, but then we realize it's a semicircle, and so we change the pi r squared to 1/2 pi r squared. And then we write those variables out because we don't want to lose our variables. We just want to write down what they are so we don't lose them and so we know what we're looking for. Because in this case, look, that's not a radius, that is a diameter. And so we need to change it to a radius as to what it was is the 4 that we were looking for. So now this time my radius is 4, so I substitute that in. And remember, you have to do the 4 squared first because we are evaluating this and finishing the problem. So 4 squared is 16, and then we take half of 16 and we get 8 pi. I can go straight to that 8 pi, putting the coefficient in front of the pi. That's fine. So that is in terms of pi, but let's go ahead and go to the nearest hundredth. So 8 times pi would be 8 times 3.14, which is 25.12 centimeters squared. So the big thing here today was just what is the formula and how do you substitute into the formula and evaluate it. So here's what I would like you to do. I would like you to write the formula for the area of the circle 5 times before we see you again in class. Thank you so much for joining us on areas of circles, and I hope that that beginning part made a little sense because it is kind of interesting to see where it comes from. Thank you so much for joining us, and remember, be kind to one another because we can all use some extra kindness in our lives. Bye for now.